Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is 4-chlorobenzyl bromide, Cl on one end of paraphenylene, CH2Br on the other end. Moving on to the next step. When 4-chlorobenzyl bromide is treated with Mg in dry H2O, a Grignard reagent forms. Mg selectively inserts into the C-Br bond of the benzylic bromide. C-Br is more reactive than the aryl C-Cl bond toward Mg. Therefore, A is equal to 4-ClC6H4CH to MgBr, 4-chlorobenzyl magnesium bromide. The aryl C-Cl bond remains intact because aryl chlorides react much more slowly with Mg under these mild conditions compared to benzylic alkyl bromides. Moving on to the next step. The Grignard reagent, A, acts as a nucleophile and attacks the carbonyl carbon of acetaldehyde, CH3ChO. The benzyl carbanion, 4-ClC6H4CH2 attacks CH3ChO to give, after workup with H3O+, the alcohol, 4-ClC6H4CH2CH of CH3. And for the final step, protonation of the magnesium alkoxide intermediate gives the free alcohol B is equal to 1,4-chlorophenyl, propan, 2-ol, ICl, paraphenylene, CH2CH, of CH3. A. Incorrect. This would require the Grignard to have reacted at the aryl Cl position while retaining the CH2Br, which does not happen. C. Incorrect. This implies reaction at both positions of the ring, which is not what occurs under these selective conditions. D. Incorrect. This would be an elimination product, not a Grignard addition product. Option B matches exactly the product of benzylic Grignard addition to acetaldehyde with intact aryl chloride. Therefore, the correct answer is B. Therefore, the correct answer is option B.